Okay, so we did branched alkanes last. If you flip your paper, there's some examples. I don't have them done. And then we're going to flip all the way to, okay, this functional group page. Just do this. Okay, I took out functional groups, so we're not going to worry about functional groups. So just put an X through the functional group page. Okay, and then we are moving on to the alcohols. Which is just, it's like adding a branch on. That's all it is. It's just a little bit different naming.
Oh, jeez.
Okay. Okay, so alcohols are carbon molecules that have an attached hydroxyl group. Okay, and a hydroxyl group is just a hydroxide. It's an OH. With the nomenclature, we're just doing the exact same thing that we've been doing. The only difference is that at the ending, instead of the ane, the een, or the ein, you're going to drop the e, and you're going to put OL on the end. And then again, just like with our double and triple bonds, you need to make sure you put what carbon that hydroxide is on. So let's go ahead and do some examples. All right, 2-propanol. So prop, that's how many carbons? Propane, 3. So I'm going to do the line angle formula first. So 1, 2, 3. Okay. The 2 out in front refers to where that OH group is. Okay, that's why it ends in OL, propanol, all meaning that you have an OH group attached. So it's on carbon 2, so 1, 2, and you're just gonna, it's like putting a methyl on, but you're putting that hydroxide at the end. Okay, there's no carbon here, it's just showing that attachment of the oxygen to the carbon on the main chain. All right, and then for the formula, it's going to be the same formula you're going to use for either your alkane, alkene, or alkyne. What you're going to do is subtract a hydrogen and add an OH on the end. OL is for the name. Okay, so for example, this one is an alkane, right? So if I look at propane, just propane, that's 3 carbons. And then it's going to be 2N plus 2. So 6 plus 2, 8 hydrogens. So by adding that OH, I'm going to do C3. I'm going to subtract one of these hydrogens. So H7. And then just add OH to the end. Okay, so you just decrease your number of hydrogens by 1. Slap on an OH on the end. Right? Slap it on. Don't add the OH into like the H's there. You wanted that separate. All right, 1-octanol. Oc, how many is that? 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. My OH group is going to be on 1. So I'm just going to put a little dash here with an OH. And then for my formula, again, this is a alkane, so CnH2n plus 2. So C8H2n plus 2, so that's 18. So I'm going to subtract 1, 17 with an OH. Don't ask questions. Because, so originally, if this was just the alkane, that would be a hydrogen on the end. So I've removed that hydrogen and I've replaced it with an OH.
Okay. Oh.
Okay, so you just subtract, you're taking away one hydrogen, and instead of hydrogen you have OH.
That makes sense.
Okay. All right, let's do a fun one.
I know it's not going to be fun.
Oh, it's not that bad.
Wait, so there's a 5 in between.
Yeah.
Okay.
Yes. Interesting.
I don't like that.
There's a reason that it has to be in the middle there. The number has to be in the middle. Because you have a double bond too. Okay. So let's take a look at this. So first off, I'm going to draw, I always do this with all of them. I always draw my main chain like it's a alkane, like there's only single bonds, because then you can build off of that. So we have undec, which is how many? 11. So we need 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. All right, so there's a lot going on here, right? So you can start at the end and work your way to the front, or you can add your branches, however you want to do it. I'm going to add my branches first, and then I'm going to add my, there's a double bond in here as well as an alcohol, like the OH, right, the hydroxyl group. So for ethyl, so 1, 2, 3, 4, I'm going to put an ethyl. It's a little straight, but that's okay. 3 methyl, 1, 2, 3. Okay, and then let's deal with the mess on the end. So if we look, there's a reason that 5 is separating, right? Because that 5 tells us where the double bond is, okay? Notice how it's in front of the EN? Okay, that 5 is in front of the EN telling you that double bond is on 5. Okay, so 1, 2, 3, 4, 5. So we're going to put a double bond here. Okay, because this is telling you where that is. This 2 is telling you where the OH is. Okay.
That makes me mad.
It's just the way it is. Well, the 5 is right in front of the EN.
Yeah,
And then the 2 is for the O. But it's not, but see, like, it's the EN is the double bond, the OL is the hydroxyl group. Alright, so then 2 gets the hydroxyl group, so 1, 2, put an OH there, and there you go. Now, this is a ene, so that's a double bond. So that's CnH2n. So we need to count up our carbons first. So we have 11, 12, 13, 14. So 2n would be 28 minus 1. So 27, and then OH on the end. Because there's 11 in the main chain, right? And then 1, 2, 3. No, the double bond is just between 2 carbons. So you already have counted those carbons. Because they're in the main chain, right? Okay? So we're kind of just adding on one more kind of branch. It's just adding on a different branch. So remember that your ending is going to end in OL if you have that hydroxyl group. Okay. All right, so go ahead. You're going to do all of worksheet 7. Okay, this is front and back for worksheet 7, and you have the rest of class to work on that. Tomorrow we're going to go through, I'm going to pass back your acids quiz. We'll go through review stuff. I'll have a review worksheet for you. And then the majority is going to be practice. If you haven't done, you can turn them in, yeah.
Oh.